students, we are studying chapter number 1, that is gravitation. In today's video, we are going to learn about very important part of the chapter, that is Kepler's laws of planetary motion. So students, in 16th century, many astronomers studied the space with their naked eyes. At that time, no any advanced equipments were present to study the space. They collected some data and put some theories too. And after some time, by analyzing their data and theories, the scientist Johann Kepler, he derived some laws regarding the planetary motion. And their laws are well known as the Kepler's laws of planetary motion. So students, today we will learn about their laws. To study these laws, we have to know ellipse. So first, we will see about the geometrical shape ellipse. See here, this is a geometrical shape and ellipse. So students, we get this shape by cutting any conical shape into inclined angle. Suppose this is a conical cap. If we cut this cap in this way, in an inclined angle, then we get shape here that is an ellipse. About the ellipse, or the property of ellipse is that it is having two foci. It is having two foci. Foci, it is a plural word. If single center is present, we say it as a focus. Okay, so here two centers are present to the ellipse. It is a property of ellipse. So we call it as two foci. So students, see very carefully. We consider the first foci of this ellipse as F1 and another foci as F2. And suppose I am present on this F1. Again, we will consider here 2 points on the ellipse named A and B. Okay, now I am here at F1. Then I moves to A. I moves to point A and after that come on second foci, that is F2. Okay, just see here the distance that I covered. Now again from F2 I go to B. I go to point B and come back to first foci, that is F1. Now the distance that I covered here from F1 to A and again A to F2 means this distance is equal to the distance F2 to B and B to F1. Okay, means these two distances are equal. See here, F1A plus F2A is equals to F2B plus F1B. Okay, means if we take any point on ellipse, their distance from the foci, both of its foci are equal. Let's suppose we'll take here another point, that is C. Then when I move from F1 to C and C to again F2, then this distance is again equal to both these distances. Means here F1C plus F2C is equal to these two distances. Understand? If we take any point on ellipse, then their distance is equal from both of its foci. So this is about the ellipse. Now we will see the laws of planetary motions which derived by Kepler, Johann Kepler. Students, we know we are present in a galaxy Milky Way and Sun is the center of our galaxy, and remaining all the planets, these are revolving around the Sun. So according to Kepler, these planets that revolving around the Sun, these are in elliptical orbit. These moves around the Sun in elliptical path and Sun is present at its one foci. Let us see this through a diagram. Suppose this is an ellipse again. Okay, So planets revolve around the sun in this path. We know ellipse having two foci and sun is present at one of its foci. Either it is present here or sun is present here. Let's suppose sun is here. So it is sun. Okay. So planets, we consider a single planet, path of single planet. Suppose planet is here and it revolves around the sun in this way in an elliptical orbit. So the first law of Kepler states that planets revolving or revolves around the sun in elliptical orbit and sun is present is at its one foci. Okay, so this is the first law of Kepler's planetary motion. Planets revolving around the sun in elliptical orbit and sun is present at one of its foci. Okay, now come to the second law of planetary motion. Now students, see this diagram again. The line that joins sun and planet. The line that joins sun and planet, it sweeps a distance. Sweeps means what? Cover. It covers a distance. Okay. It covers it covers area. It covers a distance. It covers equal area in equal interval of time. Okay. Just suppose this planet, or this is the starting point of the planet. In 1 hour, this planet covers this distance. This planet covers this distance, means it sweeps or it covers this all area. Okay. Now, if anywhere we consider the distance that covered by planet in 1 hour, it is same, or this area will be same. Means in 1 hour planets moves here to here. Means it sweeps this all area. Okay, and both of these areas are equal. Again, suppose planet is here and in 1 hour it reaches at this point. Means in 1 hour same planet covers this area. Same planet covers this area, and all that areas that covered by planet within 1 hour everywhere in their elliptical path. In 1 hour all these distances or all these areas are equal. So the second law of Kepler's planetary motion states that the line that joins sun and planet, covers or sweeps equal area in equal interval of time. Okay, equal area in equal interval of time. Let us write here the line that joins planet and sun sweeps equal area in equal interval of time. Okay students, understand this? Now come to the third law of Kepler's planetary motion. So according to third law, just see, every planet completes their revolution around the sun in specific time period. Suppose this planet, this is the starting point of this planet, and when it moves around the sun and again back to this point, then it completes their one revolution. Means it gets a specific time to complete their one revolution. And according to third law of planetary motion is that the time period or revolution time period of planet the square of revolution time period of planet is directly proportional to the average distance from planet to sun. The average distance from planet to sun. So students, first we will write that statement here. The time period, the square of time period of revolution of planet is directly proportional to average distance from sun to planet, Now students, see here, average distance means the distance from sun to planet at everywhere in their elliptical path is changes. So we have to take here average distance from sun to planet. Average distance from sun to planet. So cube of that distance. Okay, we consider here cube of that distance. And time period or period of revolution of planet. So it also write as the T. Time period or revolution time we considered as capital T, means T square is directly proportional to R cube. Okay, R cube, where R is what? Average distance from sun to planet. Okay, so in this way the third law states. Okay, so it also can be written as the T square is equals to K into R cube. Okay, where K is what? Proportionality constant. So it also becomes therefore T square upon R cube equals to K. So remember this very carefully. So this is about the Kepler's laws of planetary motion. So students, in the next video we are going to learn about the universal law of gravitation. Till then, thank you.